by looking at work, power, and energy. So I'm actually going to start with what work is. And work basically is where you take a force and apply it to an object, and that object has to move a particular distance. And usually on the second bullet here, and let me get my pen on here, work is done when a force acts on an object in the direction of that object. Okay, so for instance, when you see this diagram right over here, when this book is lifted upward, okay, it's defying gravity, it's lifted upward, it's actually moving in the direction that the force is pushing upward. Or if you take an object and you drop it, it falls down because gravity is pushing down on it. If an object does not move, then no work is actually being done. So the formula for work is equal to force times distance. So when I look at this one, remember side by side, we're actually going to multiply. And think of that line right there as your division line. It's your division line. So if it's on top, take that number divided by one of these that are on the bottom. Now the unit for work is called a joule. Now let's go back up here. A force is measured in newtons. A distance, we're actually going to measure it in meters. Okay, so a newton meter is actually a joule. Okay, so we have some work problems right here. So let me draw my little triangle up at the top. Okay, and remember the formula for work. Work is equal to the force, which is in newtons, multiplied times distance. Force times distance gives me work. So up here, this first one, we got a man weighing 750 newtons, climbs a flight of stairs 5 meters high. And they want to know how much work. Well, I'm looking for work. I have two numbers there, so therefore I'm going to fill these in. A newton is a force, and a meter is your distance. So we're actually going to multiply these two. And when I multiply 750 by 5, let's see, I get 0. 5 times 5 is 25. 5 times 7 is 35. 36, 37. I get 3,700, and work is measured in joules. Okay? Now, let's look at number 2. We got a 10 Newton book. Remember, Newton is a force. Is raised 500 meters. There's your distance. So here I have a force. This one right here is my distance. And the formula to find your work, remember it's force times distance. 10 times 500 is 5,000. And the unit for that would be a joule. Okay? So we're provided the force and the distance, we multiply it. Now the next one, we're looking for force. We're looking for force, so that means work is provided. Remember, work is your joule. That goes on top. So that's 40 joules. And we're actually going to divide that by 30 meters. Okay, so if I take on here, cross out the zeros, 4 divided by 3, and that would be 1 point, and I don't have my calculator handy, but it's 1 and some on there. So let's do this. 4 divided by 3. It'll go in there one time. And that's 1, bring down 0. So it's 1.3 repeating. 1.3 repeating. And on that one, the force on this case is a Newton. Okay? So, number 4, David pulls 450 Newton sofa up the stairs, producing 25 joules of work. And they want to know how far, and far is your distance. That means we're going to solve for the meter, and distance is here. That means I've got work and I've got a force. So my work is 25, and we're going to divide that by 450. Okay? So when I take 25 divided by 450, let's pull out our calculator on that one. So it would be 25 divided by 450. I get 0.0, and I'm going to round that to the nearest tenths. 0.06, or if you wanted to round it to the nearest tenth instead of hundredth here, 0.1. And on here, how far would be a meter? Okay. Now the last one is we've got a 100 kilogram object, and it is pulled vertically upward 5 meters by rope with an acceleration of 1 meter per second squared. They want to know how much work was done by the tension of the force in the rope. So, first of all, when I look at this, work is force times distance. Well, first of all, I need to figure out a force because I don't have a joule here. So, force is equal to mass times acceleration. So when I know that, my mass is in kilograms, so that would be 100. And my acceleration, well, there it is. It's 1 meter per second squared. So 100 times 1 is 100. And therefore, it would be 100 newtons. Okay? Now, we want to solve for work. Work is force times distance, and it travels 5 meters. So we're going to take the 100 newtons, we're going to multiply it times 5 meters, and I get 500, and work is measured in joules. Okay? If you have any questions, please ask your teacher. Now let's go to power. And power is a rate problem, and power indicates how the rate at which work is being done. So power or rate problems usually are something over time. Speed is a rate problem where it's distance divided by time. Power would be how much work you do in a given amount of time. Okay? If you do it at a faster rate, then what's happening there? You're performing a lot of work in a little amount of time. To increase power, you can increase the amount of work done in a given amount of time. Now here's the formula for power. It is work divided, power is equal to work divided by time. Okay? So, let me get my pen and identify it. Work is measured in joules. Time is in seconds. And your power is measured in watts. W-A-T-T. Like a light bulb. Okay? And that's going to be crucial to remember later when we talk about electrical energy. Okay, now let's practice some power problems here. So the first one says, oh, and let me start by writing our triangle up here so that we have it. So remember on my triangle up here is that power is equal to work divided by time. Okay? So on here, I have work, 2,000 joules. I have 25 seconds. So now we're going to take the 2,000 joules, which would go up top. My time would go down here. So pulling out your calculator now, we're going to take 2,000 and we're going to divide it by 25. And when I do that, I get 80. And they want to know the unit for power, and it is a watt, or on this case it's plural because it's 80, so it's going to be watts. Okay, now the next one, Sean does 125 joules of work. Remember, joules is up top, that's work, in 50 seconds. Okay, so knowing one's on top, one's on the bottom, we're going to divide. So I take 125 joules and I'm going to divide it by 50. All right, so pulling out your calculator, 125 divided by 50, you get 2.5. You get 2.5. And power is in watts. Okay? Now let's look at this one. Kayla produces 20 watts of power in 0.5 seconds. Power, time. Power, time. Side by side, you multiply. So in this case, we're going to take the 20 watts and we're going to multiply it times 0.5 seconds. Okay? So when you multiply 20 times 0.5, it's like taking half of it. You get 10 on here because we're measuring how much work. So 10 joules would be the answer. Okay, let's look at number 4. Jacob does 400 joules of work to produce 15 watts of power. How long did he work? And that means time. So we're going to put our joules for work on top. So that would be 400 joules. And then we're going to divide that by 15 watts. Okay, now let's pull out our calculator here. 400, and we're going to divide that by 15 watts. And long meaning time. Let's round it to the nearest second. So that would be 27 seconds. Okay, now the last one, Beth moves 15 Newton book 20 meters in 10 seconds. Now I know the time goes on the bottom, but remember work is force times distance. Force times distance. So in this case, we're going to multiply 15 times 20. And whatever I get there, then I'm going to divide it by 10. Okay, so 15 times 20, I get 300, and we're going to take 300 and divide it by 10. That means just get rid of a 0. So your answer is 30 on here, watts. 30 watts is your answer. Okay, any questions? Okay. All right, let's move on. Now, energy is the ability to do work. And energy, just like work, is also measured in joules. And there are two types. You got kinetic, which is energy in motion, which is what you're seeing here, with the sun rising and setting, and also potential. It's being stored. So like if I have solar panels, it collects it, it's being stored until I use it. So here we have kinetic energy, and when you look at this roller coaster that we have here, as you're click, 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 click going up, you can see how potential energy increases, but as gravity is pushing you down and moving faster, you're changing it to kinetic energy. But then as you're rising up, defying gravity, potential energy goes up. Okay? Now the formula for kinetic energy is half of the mass times your velocity squared. So you're going to take whatever it is in kilograms, and let me write the units here. Mass is measured in kilograms, okay? And your velocity is a meter per second, okay? The velocity is a meter per second, and then we're going to square whatever that value is. Okay, now let's look at 3 problems here. The first one is, and kinetic energy. Let me set this up in a triangle for you. When I set it up in a triangle, kinetic energy is equal to half of your mass, and then we're going to square your speed or velocity, and that is kinetic energy. So when I look at the first question here, I got a 3 kilogram ball. Kilogram is mass, so I'm going to take half of 3. And half of 3 would be 1.5. Okay? And that ball is rolling at a speed of 2 meters per second. But now I have to square it. Okay, so 2 squared would be 4. So on there it would be a meter per second. Okay, on there. And they want to know how much kinetic energy would it be. So now I'm going to have to multiply 1.5 times 4. When you multiply those two together, you get 60. And on here, how much energy? Energy is same as work. It's measured in joules. Okay, number 2, determine the kinetic energy of a 625 kilometer roller coaster car that is moving with the speed of 18 meters per second. So remember, kinetic energy is half of the mass. So we're going to take half of 625. So let's do that right now on our calculator. 625 divided by 2. I get 312.5. So I'm going to write that down. 312.5. And that would be your kinetic energy, half of the mass, okay? And now we're going to multiply that times the speed squared. So now I've got to square 18. So 18 times 18, or 8, and then hit the x squared button, is 324. So we're going to multiply these two numbers together, 324 times 3 times 312.5. You get 101,000. So let me get this going. You got 101,000. Yep, 101,250. 250 on here, and that would be joules of work. Okay? The last one, we got a 30 kilogram car So the mass kilograms, we're going to take half of the mass. So that's 15. And then we're going to multiply it times a speed of 5 meters per second. So that would be 5 squared is 25 meters per second. Or meters per second on there. Okay. And now we're going to multiply 15 times 25. When I do that, I get 168,000. 168,750. All right, and these are kinetic energy, which is a joule. Okay. All right. Any questions with the kinetic energy? All right, now potential energy is basically stored. It's energy that is stored. So here's a key word right there, stored, as a result of a position or your shape. And the formula for that is mass times gravity times height. So what we're going to use for gravity is 9.8 meters per second squared. Okay, so let's take this formula and apply it. And I'm going to show you on my triangle, I add a third component down on the bottom of my triangle. If you look at it right here, bring it up, right here, right here. We said it is mass times gravity times your height is equal to PE. Remember, energy, whether it's kinetic or potential, is measured in joules. Okay, mass is in kilograms. Gravity is the value, the number, 9.8 meters per second squared. And your height is measured in meters. All right, so let's take a look at the first one. We got a 4 kilogram rock. That's your mass, okay? So we're going to put 4 there. So we're going to say 4. It's sitting on a 3 meter ledge. The height's there, 3 meters. Okay. And they want to know how much potential energy does it have. So you got the gravity, you got the height. Let's get the mass, or excuse me, we have 4 kilograms, 3 meters on a ledge. Okay. And then what we're going to do is place gravity in there, which is 9.8. So we're going to take this number, multiply it times 9.8. And then we're going to multiply it times your height. And on that one, it's 3 meters. Okay, so if I take 4.3 times 9.8 times 3 equals, I get 126.42. So it's 126.42. 42. And on that one, it is potential energy, just like kinetic energy is measured in joules. Okay. The next one, we got a 625 kilogram roller coaster, and it's sitting at the top of the hill, and it's 90 meters from the ground. What is the coaster's potential energy? Okay, so if I know that that roller coaster is going to have on there 190 on there, so this formula right here for potential energy, we're going to take, first of all, our mass, which is 625, we're going to take half of it. So using your calculator, take 625 divided by 2, and I get 312.5. So I'm going to write that down. So I get 312.5. Okay. It says that the roller coaster is sitting on top of the hill 90 meters from the ground, so that's your height. So we're going to multiply the height, which is 90 meters. So I'm just going to put 90 there. And then the final thing is, what is the coaster's potential energy? So we'll get to that in just a second. So let's multiply what we know. We got our mass, we have our H there, but we don't have gravity, and gravity is 9.8 meters per second squared. All right, so what I'm going to do is plug in 32.5 plus 90 plus 9.8 equals, and then we're going to divide it by those three sites, and I get around 44.1. Okay, 0.1. So this one right here is energy, so it's measured in joules as well. So it's 44.1 joules. All right, now the last problem on here, our book has 40 joules of potential energy when it is 5 meters from the ground. What is the book's mass? Okay, so let's plug in what we know of these two numbers. The joules of work right here has 40 joules, and it's of potential energy. So we're going to put that one up at the top at 40. Okay, when it is 5 meters from the ground, okay, your height would be 5 meters there. What is the book's issue? So I think on this one, we have the gravity, which would be 9.8 meters per second squared. We have a mass, which is 40 joules, or excuse me, no, it's not. So we need to find the mass, or that's what we're solving for, is the mass. What we have right here is we have our distance, the height, 5 meters. We have the potential energy is 40. So on here, what we're going to do, we're going to divide 40 by 5. And when you divide 40 by 5, you should get 9. Not 9, 8. Should get 8. Okay? So that is the book's mass. Okay? Now there are some other ways you can transfer energy. Mechanical just means things moving to something else moving. Thermal is when you're measuring the particles, like these fires that are out west. You're going to measure the fires and see about the internal motion of the particles in the air and on land as well. Chemical means you're looking at the chemical changes and the bonds of different items. Okay? Nuclear, what we have for nuclear is the splitting of atoms on there. And then the electromagnetic spectrum or electrical charges are just showing how the spectrum, light waves, electromagnets are all interconnected and showing how things can be transferred from one form to another. The law of conservation of energy says energy can neither be created nor destroyed. I'm just going to transfer or use its form from one to another as we move on. And on here, this graphic right here also helps you understand the difference between potential and kinetic. So what we have over here is potential's at the greatest up at the top, but as it's falling down, then it's going to be converting from just a potential energy moving down the ramp. We're seeing also it's starting to level off, and then we see some changes there. Oops. Let's see. Also with the pendulum, when you look at this one, potential energy would be at its greatest on those ends. What we have right here, I'm going to put PE right here. These are at the highest, so if it's high on one end, it'll be high also on the end as well. The other thing where potential energy is changing, potential energy as you move downward towards 3, that is your highest kinetic energy. Okay? That is your highest kinetic energy. Therefore, that's where we're seeing a lot of changes. It's whoosh, going back and forth on there. So if I label these, number 1 is where potential energy is its greatest. At level 2, potential energy starts to decrease and kinetic energy increases. And number 3, that's where your kinetic energy is the greatest amount. And then as you're moving back over to the other side, your kinetic energy and your potential energy are again in flux. And then what we have at the end, at the top up there, is where potential energy is its greatest in there. And we're not going to worry about projectile motion. All right. Well, I hope this helped, and I will see you. Okay?